Now we start off on the topic partial differentiation. Here we are considering derivatives of functions of both x and y. How then do we do the differentiation with respect to one variable when the function has got both? So the first thing we do, if we want to find the derivative with respect to x, then we hold y a constant and then differentiate the function with respect to x as if y is a constant. So that means if you're differentiating y with respect to x, it's not going to be y prime, but it will be 0 because we are saying we are treating y as a constant. Same as when we are differentiating with respect to y, we hold x as a constant. That means whatever differentiation rule that is applicable to a constant, you also apply it to the variable that is being held as a constant at that particular moment. Some notations that we'll need to know throughout this section. Firstly, if z is a function of both x and y, then we can be able to differentiate z with respect to x. So that means say dz over dx, sometimes pronounced as double z over double x, but we'll stick with dz over dx. And then also we can use f subscript x, referring to the fact that f, although it's a function of both x and y, we are differentiating only with respect to x and holding y a constant. Same as we are differentiating with respect to y, then we will have f subscript y, or dz over dy, or df over dy. Let's do a few examples so that we can be able to illustrate how partial differentiation works. Here, we've been asked to find both fx and fy. That is f subscript x and f subscript y, meaning we're differentiating f with respect to x, find the answers, and then f, we differentiate it with respect to y and get the answers. So for number 1, our function is x squared plus 3xy plus y minus 1, and we are asked to evaluate it at the point 4, negative 5. Now, if we want the derivative of f with respect to x, the first thing we need to remember, y must be held as a constant. Now note, we've got x squared, so differentiating with x, we know the derivative of x squared is 2x. And the derivative of 3xy, because y is a constant, then that means we take out 3y and then differentiate x. Hence the answer is 3y. Note the difference between partial differentiation and implicit differentiation. Don't make the mistake, they are not the same at all. For partial differentiation, you take the other variable out as a constant, or you treat it as a constant. So we go to the third term. The third term has only got y. Because y is being treated as a constant, the derivative of a constant is 0. And thus the derivative of minus 1 also is 0. So we've got our derivative of f with respect to x as 2x plus 3y. And then, because we've been given a point where we ought to evaluate our derivative, we substitute for the values of x and y. X is 4 and y is negative 5. Please check whether your answer will also be negative 7. Going to the derivative with respect to y, note now we are holding x as a constant. So if x is a constant, so that means the derivative of x squared is 0. because x is a constant when we're differentiating with respect to y. Then that means we'll only differentiate the second term and the third term, because the first term and the fourth term, both of them are being treated as constants, so their derivatives are 0. So the derivative of 3xy with respect to y, please always note which variable are you using to differentiate with. So 3x is taken out, and then we differentiate y, which is 1. Second term, the derivative of y, we know is 1. Hence, the derivative of f with respect to y is 3x plus 1. And then you evaluate at the point x equal to 4 and y equal to negative 5. And please check if 13 is the correct answer. Number 2, we are given y sine xy. Note now we have a product of two functions. It will depend whether we're differentiating with x or we're differentiating with respect to y, whether we use the product rule or not. Now let's differentiate with respect to x. Remember, when you're differentiating with respect to x, y is a constant. So we take y out and differentiate sine xy. And the derivative of sine xy, we use the chain rule. First differentiate sine, it becomes cos. Remember the argument, you take it as it is, and then find the derivative of the argument. That's what the chain rule says. Note the derivative of xy, we take y as a constant, so that means the answer, the derivative of x is 1. So the answer of the derivative of xy is y. Hence, we say here y squared sine xy is the final answer because of the y that we had taken out in our first term. Now let's go to the second derivative with respect to y. Note now we have y sine of xy. So we cannot ignore that y. Y is not a constant now. We are treating x as a constant. So that means we have to use the product rule. So derivative of y is 1. Hence we have sine xy plus y times the derivative of sine xy, which we had said is cos xy, times the derivative of xy. So hence we have sine xy plus xy cos xy, because the derivative of xy with respect to y is x. Then we go to number 3. Here we are given a quotient 2y divided by y plus cos x. So when we simplified it, especially for the differentiation with respect to x, it works better to have that denominator taken up because x is in the denominator. Remember, y is held as a constant. So that means derivative of f with respect to x, we're only differentiating cos x, which is in the denominator. Hence, we took everything up. So we treat y as a constant. So that means we have here 2y taken out. And the derivative of y plus cos x all to the power negative 1. Firstly, chain rule requires us to differentiate the outer function, which is that negative 1, so the power. So that means it's negative times y plus cos x all to the power negative 2. And then thereafter, we differentiate what's inside the brackets, which is y plus cos x. And remember, y is a constant, so that means the derivative of y with respect to x is 0. So the derivative of cos x is negative sine x. Hence, our answer, simplified, is in that format. Now we go to the derivative of that very same function with respect to y. Now we cannot ignore the 2y that is in the numerator because we're only holding x as a constant. Now let's move. The derivative of that quotient will have to use the quotient rule. Quotient rule, the first rule says take the denominator up. That's what we did. Y plus cos x multiplied by the derivative of the numerator, which is 2, minus the numerator times the derivative of the denominator. Remember, x is a constant. So cos of any number gives you a number. So the derivative of a number gives you a 0. Hence, we only have the derivative of y to be equal to 1. And we remember that we divide by the denominator all squared. Number 4, we're given again another quotient, x ln y, all divided by x squared plus 1. With respect to x, this derivative requires the quotient rule, which gives us x squared plus 1 times x squared plus 1. Remember, is the denominator, so we say denominator up, and then we differentiate the numerator, which is x ln y, and remember y is taken as a constant, so that means we're only differentiating x. That gives us ln y minus the numerator times the derivative of the denominator, which is 2x. All of this is divided by the denominator squared. Please remember the reason why we use the quotient rule here, it's for the derivative of f with respect to x, is because we have x in the numerator as well as in the denominator, so the quotient rule applies. Now let's go to the derivative of f with respect to y. Remember, we take x as a constant, hence we took out all the terms that have got x, which is x divided by x squared plus 1, multiplied by the derivative of ln y. The derivative of ln y with respect to y is just 1 over y. Now please attempt number 5, 6, 7, 8, 9, and 10, applying all the rules that you know: product rule, quotient rule, the derivatives of transcendental functions, the inverse, their inverses, as well as the derivatives of square roots and the derivative of the log function. We go to chain rule for partial differentiation. Z is a function of both x and y. And now note that x is a function of t and also y is a function of t. So we have to do the chain rule. And note the function has to be differentiated according to that formula. dz over dt equal to df over dx, that means the right hand side is the one that has to be differentiated with respect to x. Note it's partial differentiation multiplied by the derivative of x with respect to t. So if you differentiate f with respect to x, then that means x also must be differentiated with respect to t, plus df over dy multiplied by dy over dt. Let's quickly use some examples to explain maybe some of the confusing steps that I've pointed out there in the definition. We have to use the chain rule to find the derivatives of the following functions. Now, number 1, we've been given that w is xy. So note that our f of xy is xy. And we've been given the path that is x equal to cos t. If you remember all these, those are parametric functions. Y equal to sine t, and t has been given to be pi over 2. So now, instead of z in that formula, we write w, and the right hand side remain the same. Now f is the right hand side of the function that we've been given, xy. So that means we're differentiating xy with respect to x multiplied by what was the formula given for x? X is cos t. So we differentiate cos t with respect to t. That forms the first term, plus the derivative of xy again, but now with respect to y for the second term, and then we differentiate y, which was given to us as sine t. Once again, f is xy. So the first term must be the derivative of xy with respect to x plus the derivative of x, and x was given to be cos t with respect to t, plus the derivative of xy with respect to y times the derivative of y with respect to t, and our y is given to be sine t. And then let's enumerate this. Remember, partial differentiation for xy with respect to x means y is a constant. Partial differentiation of xy with respect to y, that means x is a constant. Our answer becomes y, because dxy over dx gives you y. The derivative of cos t is minus sine t, and dxy over dy gives us x, and the derivative of sine t is cos t. But now note that immediately you get that answer, you have to remember we were given the formula for y and the formula for x. So substitute. Y is sine t. X is cos t. Substitute it in, multiply, and simplify. So we got cos squared t minus sine squared t to be equal to cos t to 2t. I'm hoping that you still remember from the double angle formulae. And then thereafter, substitute the value given for t, which is pi over 2. We know cos pi is negative 1. Please go through this example again and see whether you understand it. Number 2, we've been given w is equal to x squared plus y squared. And now x is cos t plus sine t, and y is cos t minus sine t, and the value for t is given to be 0. Now I need us to go through this one together. Again, we start with the formula. We know df over dx is multiplied by dx over dt plus df over dy multiplied by dy over dt. That gives us dw over dt. Now df over dx, we go back. Our f is x squared plus y squared. Y is a constant when we differentiate with respect to x, so that means we'll only have 2x there, multiplied by the derivative of x with respect to t. The derivative of cos is negative sine, and the derivative of sine t is cos t. Second term, derivative of f with respect to y, we're holding x a constant, so that gives us 2y, into the derivative of y with respect to t. Derivative of cos t is minus sine t, and the derivative of minus sine t is minus cos t. Remember what we did for number 1? When we get to this step, we had to substitute the value for x. The expression for x has been given. and the expression for y also has to be substituted, and then simplification, multiplication of those brackets, and that's what we got. Please check if I've got everything right, because I got A0 for dw over dt without substituting t equal to 0. Please check if my simplifications are correct. Now we get to implicit differentiation using partial differentiation. We do it differently compared to what we did for total differentiation. Here, the first thing that we ought to do is to make sure that the formula or the expression given is in standard format. The standard format, f of xy must be equal to 0. So should you be given any expression, make sure you simplify it and take everything on the right hand side to the left hand side and equate the whole expression to 0. That's the first thing. Secondly, in order for you to find dy over dx, the formula is minus the derivative of f with respect to x in the numerator divided by the derivative of f with respect to y. Please don't twist them around. Yes, on the left is dy over dx, but on the right hand side, the derivative with respect to x is in the numerator, and the derivative of the with respect to y is in the denominator. Let's do some examples to find dy over dx for expressions that have got both x and y using partial differentiation. Now we've been given y squared minus x squared minus sine xy equal to 0. It's already in standard form. Nothing needs to be changed. All we need to do is to find the derivative of that expression with respect to x and also with respect to y, and then substitute. The derivative of f with respect to x, note that y is a constant, so we'll have minus 2x minus the derivative of sine xy, which is cos xy, multiplied by the derivative of the argument with respect to x, which gives us minus 2x minus y cos xy. And then the derivative of f with respect to y. I'm hoping you're noticing that what we did there, remember f of xy must be equal to 0. So we isolated f so that we know exactly what we're differentiating. With respect to y, we're getting 2y minus the derivative of sine xy with respect to y. It means we will have cos xy times the derivative of xy with respect to y, which gives us x cos xy, and that negative does not change. And then we do our substitution. Remember that the derivative with respect to x goes to the numerator and with respect to y goes to the denominator. And there is that negative there. So we do the substitution and then thereafter multiply out by that negative, or simply take out the negative from the numerator, and that's the final answer that we get. We can't simplify it any further than that. Now please do number 2, 3, and 4. Remember, the first step is to isolate f, because already these number 2, 3, and 4 are already in standard form. So what you need to do, the first step must be to make sure that you write out what is f of xy, and then find those derivatives with respect to x and with respect to y, and then substitute into the formula. Then we have higher order partial derivatives. We're just doing first order derivatives. So here are some expressions for derivatives of higher order. Starting with the second order, note that we have fxx for second derivative with respect to x. So that means you are differentiating with respect to x twice, differentiating with y twice, or differentiating with x and then differentiating with y will be written as fxy. And then if you differentiate with respect to y first and then x, it will be fyx. And then we go to third derivatives, fourth derivatives, and so on. Let's do just a few examples. For these ones, we are asked to find all second order derivatives. So that means we are going to find fxx, fyy, fxy, and fyx, all four of them. So we've been given x cos y plus y e to the power x. Differentiating with respect to x, that means y is a constant. So we left first term becomes cos y plus y times the derivative of e to the power x is e to the power x. If you go for the second derivative with respect to x, cos y is a constant. So that means it becomes 0. And then we'll be left with the derivative of y e to the power x, which will just be y e to the power x. And then from the first derivative with respect to x, now we have to differentiate with respect to y, finding f x y. That means now we are holding x a constant. So that means differentiating cos y, and it gives us negative sine y. And then we differentiate y e to the power x. That means we are going to be left with e to the power x because x remains a constant. Let's go to the other side. When we differentiate with respect to y, now let's check if that's done correctly. With respect to y, x is a constant, so the derivative of cos y is negative sine y. And then we have that x, which we take out as a constant. And then we go to the second term, the derivative of y e to the power x will just be equal to e to the power x, because remember, we're differentiating with respect to y. Now let's do it the second time, because now we're moving from first to second derivative. Now, again, from the first derivative, we're just going to differentiate sine y only, because that's the only function of y. And the derivative of sine y is cos y. So hence we have that. The derivative of e to the power x, because x is held a constant, and e to the power any constant can be done using your calculators. E to the power 0, e to the power 1, e to the power 5 can be done calculated through the use of your calculators. So it's a constant. And then we go to the mixed derivative, where we move from the derivative of y with the to the derivative with respect to x. Now, from the first derivative with respect to y, x is what we're using. Y remains a constant. So sine y will be a constant here. Then we'll have the first term as negative sine y. And the derivative of e to the power x we know is e to the power x. I'm hoping that we getting the mixed derivative part. For this first one, we differentiated f with respect to x, and then we are differentiating now with respect to y. That means we're changing. We're holding x, the constant, differentiate with y. But if we are got the derivative of f with respect to y, and we are going to the mixed derivative, which is now differentiating with respect to x, it means you are holding y a constant as you get the answer. I'm hoping that you're noticing. fxy and fyx. Don't they give you the same answer? They do. But we'll move forward so that we can hear what Clairaut's theorem says about that. For number 2, for the given function, the first derivative with respect to x is just equal to y because all the other terms have got y only. So the second term becomes 0 when you hold y the constant. And then we go to the second derivative. From the first to the second, there is no x in the first one, so our answer is 0. And also from the first to the mixed derivative, where now the first derivative is differentiated with respect to y, our answer becomes 1. Now we go on to the derivative with respect to y. That means both terms of that given function have to be differentiated because both of them contain the variable y. So the first term, when it comes to the first derivatives, become x. And then we go to the second term. Note that it's a quotient, so a quotient rule has to be applied. Please check whether the quotient rule has been applied appropriately. Now going for the second derivative with respect to y, I've left it with a question mark because I would like to see how you are going to find that second derivative. Note that the first term is x in the first derivative with respect to y, hence it doesn't feature in the second derivative because we know the derivative of x with respect to y will give you a 0. So the only differentiation that we're left with is of the second term. What will be the answer for fyy? And then we move from the first derivative to the mixed derivative where we now differentiate with respect to x, and we see that our answer is just 1. Once again, fxy and fyx, they give us the same answer. Hence then Clairaut states that if the point given, which is AB, is in that particular disk where both fxy and fyx are continuous, then that equality holds. That f of xy and f of y, fxy and fyx at the point AB, they are both equal. Number 3, we have arctan of y over x squared. The first derivative, please check whether I used the definition of the derivative of arctan correctly, as well as the chain rule. Do we really get that solution? Also, the mixed derivative, fxy. Did we do it right? As well as fy and fyx, and continue to find fxx. My mouse is not working properly here. I'm hoping that we're able to see what I'm writing, as well as fyy. Let's check whether you are going to be able to do that. And we Please simplify as far as possible. Find fxx and fyy for this problem. And also check the equality of fxy and fyx, whether the simplifications are correct. And do the exercises from 4 to 9. And please work on them diligently, and please check each and every step of your evaluations and calculations. Note that I've given you some will use quotient rule, some that look like you'll need quotient rule but you won't, and then transcendentals and inverse trig functions also there. Square root, product rule is also there. Chain rule is also there. Please check which ones are applicable for each and every problem.